It's great to be here, really is. Let me give a little history of what I've done. You know, I'm trained as a family physician, and my newsletter goes out to about 1 million people. We have 10 million unique visitors a month, and we've been doing it for about 18 years. And for the first 3 years, we didn't sell any products, and John was the first product, aside from a cookbook that I think that we sold. So I think I flew down there, and I think it wasn't a commercial airline. Maybe it seemed like a really small plane at the time. And we met, and that was 15 years ago. So I've been passionate about this for a long time. But I was surprised when I was asked to speak here. I was expecting a much older group. And it's great to see so many younger people here. That is just awesome because, you know, that is really what we need. It's no question about it. And, you know, I'm also very excited that the Grass-Fed Exchange and the American Grass-Fed Association and Allen Savory Institute are all starting to work together now. 3 years ago, I was in Boulder, Colorado with my team, and we went to his first institute in the United States, which was, I think, 3 years ago in July. It was in Boulder, and that was really intriguing. So I'm just glad to see everything improving. But I've been passionate about regenerative agriculture now for a long time, and many of my mentors are in this room that have taught me some really profoundly important principles to regenerate the soil, because if we don't, we know topsoil is going to be gone in 50 years. And then what do we do to grow our food? So I have personally, I've got a small piece of property. I've got a 1/4 acre of plantable land where I live. And it was mostly filled when I moved in 3 years ago with ornamentals. And I removed about 90% of them, including the lawn, and put in about half a million pounds of wood chips. Because I live in Florida, so there's a lot of sand there. So you got to create soil, and putting carbon in is, of course, a really good way to do that. But one of the basic principles about, well, let me give me a little bit more history, because many of you don't know about where I'm coming from, but I'm trained as a family physician, and I've seen tens of thousands of patients before I shifted over full-time to the newsletter. And my passion, my absolute passion, is using food and nutrition as a primary tool to optimize your health. And there's a lot of ways that I could have went with this presentation, but I thought one of the best ways that would serve you the best, because I've seen in my interaction with many people who are in this field that they're doing the hard work. They're out there producing our food, because, you know, the bulk of the population does not grow their food, unlike like a century ago when the bulk of the people were growing their own food. I'm sort of back to that. Many of you do that. I grow a significant percentage of my food now, and it's just great to go in your backyard and pick it. But what I've noticed is that many people growing the food aren't that healthy, and that's really tragic. And it doesn't have to be that way, because there's some simple, let me emphasize, simple things that you can do that will radically transform your health. Now, the good news for you today is I thought I only had 45 minutes. So I got a 45-minute presentation, but I think I got an hour and a half to go over this. So it gives you an opportunity to ask questions, and we'll dialogue. So if you have a question, raise your hand and scream so I can hear it, and we'll answer it. So, problem. Eating real food is a solution that most of us here understand and appreciate. That's why we're doing what we do. But that's not what Americans eat. 90% of the food calories that Americans consume are processed. That is the crux of the problem. That's why people are getting sick, to a large part. And this came out just the last month or two. New study shows that not only is 90% processed, but 60%, nearly 2/3, is ultra-processed. Junk food that you buy in the gas station. That's insane when you think about it. More than half the food people eat today in the United States can be purchased in your gas station. Does that make sense? Here's one of the things that happen. Look around you. Look around you. Half of us are diabetic or pre-diabetic. Half of us. That's a huge problem. Part of the other issue is not only are we eating this ultra-fat processed foods, but we're not eating it at home. This is a graph that just came out earlier this year. And if you see the section in the green, there's an increasing percentage of food that's consumed away from home in restaurants. Now, when you're events like this, you don't have a choice. You're not going to be bringing in your food. You're going to eat out. So clearly there's going to be some percentage. But it shouldn't be half of your food is eaten away from home. You know, I'm sure, I like most of you, I probably 95% of my food is eaten at home. But don't worry. You know why? There is light at the end of the tunnel. Now, this, for those of you who don't know, is a Holstein cow. Do you know what this Holstein cow eats for food? That's a two components of this. What are they supposed to eat and what are they eating now? Because it's a very powerful illustration. What are they eating? They're eating grass, right? They're supposed to be eating grass? Is that right? But do you think that that's a high-carb diet or a high-fat diet? Who says high-carb? Who says high-fat? Who's not thinking? All right, most of you. Well, you would think it's high-carb, right? Because it's grass. That's pretty much all they're designed to eat. But the reality is that grass is very, very low in net carbs. Net carbs is a carbohydrate that your body consumes and converts as glucose to fuel. Most of that grass is indigestible fiber that they can't extract glucose from. So how do they survive? Well, you know they have multiple stomachs. They eat the grass, and in those stomachs are bacteria that thrive on this fiber. They convert this fiber to short-chain fatty acids, specifically butyric, propionic, and butyrate. And those short-chain fats get converted by your liver to ketones. So essentially, this Holstein cow is on a high-fat diet. Unless he's a CAFO cow and he's eating grain. Then he's on a high-carb diet. And we all know what happens to those animals, right? How long does that Holstein cow live if he's given grass and nothing else? How long? Come on, you guys are the experts. I'm not the expert. How long does that cow live? 15 years? Any other guesses? 10 years? Any other guesses? 3? No, this is the Holstein cow that just ate the grass, not the one that's eating the grain. What's that? 1 year? 21, okay. Well, I don't raise cows, but I was told by the American Grass-Fed Association that cows can live to 30 or 35 years fed grass. And in fact, they can be even calving after 30 years. But when that cow is given grain, that cow will live to about 8 years. And why is this such a powerful illustration of what we're eating? Because if we're eating the way we were designed to, essentially a low net carb, high fat diet, we will reach our maximum lifespan, which at this point is about 120. If we don't, and we have a high carb diet, low fat, We're going to die prematurely. Guaranteed. No question about it. So we can learn a lesson from the cow. Now, who knows what this movie is? What's the name of this movie? It's A Wonderful Life. This was my favorite movie until this next movie. But I gotta warn you, and I would encourage every one of you to watch. Pretty much everyone in this room has seen this movie, right? I don't think you've seen this next movie. Most of you haven't. I'm sure some have. But I would encourage you to see it. But there's a warning. You can only watch this movie if you have a full box of Kleenex. Now, who would like to know what the name of that movie is? All right, we've got some hands. We've got a few people up there. So I'll do it. The Fault in Our Stars. Who has seen this movie? A few people. Did you enjoy it? It's a powerful, powerful movie, very emotionally based, and illustrates a really profound principle about what's wrong with our system, that these children are dying from cancer. This is actually, if you enjoy reading more, I am told, I didn't read the book, but I'm told the book is even better. It was very popular. It was a bestseller. And it was based on true stories. So this has been a powerful catalyst for me personally in pursuing a new passion about understanding how to optimize the food we eat to prevent this type of tragedy. I mean, this tragedy should not happen. It's a crime against humanity that people are coming down with cancer. How many people here know someone who has cancer personally? Just about every hand is up. Every hand is up. Do you know almost every single physician is clueless about what the cause of cancer is? Would you like to know the cause of cancer? Who wants to know? All right. I put the sides out of sequence, I'm sorry. This is the person that helped me understand this. This is my mentor, Dr. Ron Rosedale, and helps me understand a lot of these principles. He taught me about insulin, the importance of insulin, 21 years ago. And now he's taught me about protein importance. But that movie, Dr. Rosedale, and this book, which if you have any interest in cancer, I'd encourage you to pick up. It's called Tripping Over the Truth by Travis Christofferson. If you want the abbreviated version, go to my website, Mercola.com. Just type in Tripping Over the Truth, and I have an hour interview with him, and that's a good summary of that. But those three variables or factors, that movie, my mentor, and this book, I had an epiphany, and I knew this was going to change my life's work, and it has. And I'll tell you why. Because there's another man here. This is Professor Tom Seyfried, who is still alive. He is a professor at Boston University and is really a pioneer in helping people or helping professionals understand what the cause of cancer is, which is a metabolic disease. Now, let me give you a little history prior to Dr. Seyfried. There was a MD, PhD, probably one of the most brilliant biochemists of the 20th century. His name was Otto Warburg, received a Nobel Prize in 1931 for describing the physiology of cancer cells, almost 100 years ago. And one of his students was Krebs, and that's the Krebs of the Krebs cycle if you've ever taken biochemistry. And he actually wrote Warburg's biography. And then one of his students was Pete Peterson at Johns Hopkins, who continued his work, and then he mentored Dr. Seyfried. So he's like a third-generation Warburg disciple. But he wrote this brilliant book, and Dr. Seyfried's contribution to the understanding of cancer was profound, because almost every single cancer specialist in the United States today believes falsely that cancer is a genetic disease. It's not. Cancer is, as the title of Dr. Seyfried's book shows, is a metabolic disease. And I know that's, what does that mean? I'll describe what that means. But before I do that, let me discuss what Dr. Seyfried's findings were and why he has some very compelling evidence to show that it's not a genetic disease. If cancer was a genetic disease and it was due to defects in the nucleus of the cell, if you took that cancerous nucleus and transplanted it into a normal cell, would you expect that cell to turn cancerous? If that theory were true, right? Cancerous nucleus into a normal cell, that cell would turn cancerous. But you know what? It doesn't. The genetic defects in that nucleus normalize. And if you take the reverse, if you take a normal nucleus, a cell from the nucleus from a normal cell, and you transplant it into the cytoplasm of a cancerous cell, that nucleus turns cancerous, showing conclusively that cancer is not due to genetic damage in the nucleus, even though that's the way almost every single cancer patient is treated. Cancer really, and so what's in the cytoplasm? What's in the cytoplasm are mitochondria. Has anyone not heard of mitochondria? Raise your hand if you haven't. Okay, you've heard of it. It's in biology, but let me just give you a little review of mitochondria. They're the energy plants in our cell. And they help us, they're responsible for all the energy. We have probably 500 to 1,000 times more mitochondria than we have bacteria, and we have maybe 500 more bacteria than we do cells in our body. There's probably 500 quadrillion mitochondria in our body. And they produce energy, primarily. They produce about 85% of the energy. In fact, our bodies are incredibly energy dense. It doesn't seem like it, but you would be surprised to know that gram per gram, your body produces 10,000 times more energy output than the sun per gram. And they do that through this mitochondria. That's the primary mechanism. And these mitochondria produce something called ATP, which is as short for adenosine triphosphate. And you make a lot of it. How much is a lot? These are molecules of ATP. How much ATP do you think you might make has anyone heard of ATP? How much do you think you make in a day? How much? Remember, this is a molecule. Many guesses. An ounce, 2 ounces? Because I can tell you within a few percent what you make. Each specific person in here. Would you like to know? You make your body weight in ATP every day. That's a lot of ATP. So when you have a problem in ATP production and the ability to generate energy, you're going to have a serious problem in your health. But not only do mitochondria are they responsible for ATP, they're also responsible for cell death, a process called apoptosis. And if that process is disrupted, that leads to cancer. And they're also vitally important for cell signaling processes. So why do we get sick? There's a lot of reasons why we get sick. One of them is emotional trauma, toxins, heavy metals, food allergies and sensitivities. We don't move enough, which is probably not so much of an issue for most people here if you're in the farming lack of sleep, nutrient deficiencies, and exposure to electromagnetic fields. But one other way that we get sick, this is a theory of aging and probably cancer, is this reactive oxygen species. These are highly reactive species that occur as a side effect, an artifact of burning fuel. It's like when you burn fuel, you can burn clean fuel or dirty fuel. Like you can put in a log in that fire, and if it's a dirty fuel, you get a lot of smoke, right? Or you put in, you don't, I guess, if you burn diesel fuel in a engine that really wasn't designed for it, you get a lot of side effects. So it's a normal, natural waste product of fuel burning, these reactive oxygen species. And normally, the theory goes is that we should take antioxidants to reduce them and prevent it, like vitamin E, vitamin C, and that would help us, right? Turns out that's not a good idea, because these reactive oxygen species are actually required by a body as important signaling molecules. So you really want to be careful of it using excessive antioxidants. They can be counterproductive. This is a complex diagram that shows, you burn mitochondria. The reason why mitochondria work is that they allowed us to burn oxygen as fuel. Prior to our ancient ancestors on a cellular line, they didn't have the ability to burn oxygen because it wasn't in the air prior to plants. The plants, obviously, as the waste product of their metabolism, they generate oxygen. And then when there was oxygen in the environment, then these bacteria mutated and they developed the ability to extract fuel from it. And those bacteria actually turned into mitochondria. So ideally, oxygen goes to water, and that's clean, and there's no side effect. That's like when you're burning in a fuel cell in a car. That's clean. There's no side effects. Water is the pollution. But that doesn't happen in our cells. A certain percentage goes to superoxide, and then you have superoxide dismutase, which converts it to peroxide, and then you have peroxide, which converts it to this hydroxyl free radical, which is the most biologically destructive free radical in our body. In nanoseconds, it will decimate your mitochondrial cell membranes and mitochondrial DNA. So, actually, let me go back. Notice that there's iron in there that catalyzes that reaction. This is a key point that virtually no physician understands. Virtually none. I was one of the primary catalysts for awakening the medical community to the importance of vitamin D about 16 years ago. I mean, people heard of vitamin D. We knew for a century that it was important, but most physicians believed it was important for preventing rickets, and it was only useful for bone health. Now we know, and many physicians screen for this regularly, thank God, that it's important to prevent cancer and heart disease and hundreds of other diseases. Vitamin D is crucial. It's one of the 2 tests you need to do, and I'll talk about that in a moment. But the other one that no one knows at this time, this is like vitamin D was in 1970 when I went to medical school, okay? Virtually no one understands this. You'll know more about this than your doctor, is iron. Why is iron such an important issue? Because, we'll go back here, if your iron is elevated, it will catalyze peroxide to hydroxyl free radical. The last thing you want to do is generate excessive hydroxyl free radicals. So, as an adult male, after about 16, kids need iron. Most kids are relatively iron deficient. They need iron. If you're a menstruating woman and you're losing blood every month, you may be iron deficient. You might need iron. If you're an adult male over 16, you don't need iron unless you have a blood loss of some sort, like you have a bleeding ulcer or you had trauma. You basically are never going to need iron. So this iron just builds up. We don't excrete iron effectively. So you're wondering, Well, why don't we, why would we develop it? Why did God design us this way? Well, the biological design is only to get us to the age of reproduction, right? I mean, nature doesn't really care if we can't reproduce after that. But the problem is, if you ignore this issue, you will continue to accumulate damage and decimate your mitochondria, because high iron will prematurely damage and kill your mitochondria, which will cause not only cancer, but a whole variety of other diseases, like heart disease and diabetes and obesity and neurodegenerative diseases like Alzheimer's and Parkinson's and ALS. So it is imperative that if you're an adult male or a non-menstruating woman, I mean, you could have had a hysterectomy and you're 35, then you need to have this test. Would you like to know what the test is called? Anyone? All right. It's called serum ferritin. And the ideal range should be 40 to 60 nanograms per milliliter, which is interestingly the ideal range for vitamin D. Now, if you believe me and get this test done, your physician will not understand the results. You have to tell them what normal is. Because the lab, every reporting lab in the United States reports normal as under 300. When I graduated medical school in 1982, the normal range for cholesterol was below 300. And they changed that a few years later. It's the same state with this. They don't understand the seriousness of this issue. It's a profoundly devastating challenge, and it is far, far more important to your health than to know your cholesterol. So what do you do if it comes back at 100, 150, 200, 300, 1,000? You've got to, the best way to lower your iron is to remove your blood. So all you have to do is donate your blood. And if you can donate your blood, and you're an adult male, I couldn't more strongly encourage you to donate your blood 2 or 3 times a year. The studies are very, very, very clear. People who do this live much longer because their iron levels are lower. If you're a menstruating woman or you're iron deficient, thank God. Your iron levels are low. You haven't accumulated a lot of damage. That's a good thing. Now, as I said, the other important tests, you really only need 2 primary tests if you're interested in staying healthy. One is vitamin D, which should be done on an annual basis at least, and ferritin. You could check your cholesterol levels, but if you're going to follow what I'm recommending next, it's almost irrelevant. Because if you're eating the right foods, there's less than a 1 in 10,000 chance you'll have abnormal cholesterol. But you should have your vitamin D tested, especially now. Now this is the beginning of May, and many people are from the north. I live in Florida now, so my vitamin D levels are always high because I go out walking every day for about 2 hours in the sunshine. And I think that's the best way to get vitamin D is from exposing enough skin to the sun. But if you're unable to do that, then you could swallow pills. But because just being outside dressed like this, I would not get any significant vitamin D. I have to wear shorts and take my shirt off. Because it's how much surface area of your skin is exposed to the sun. You're a solar collector, essentially, just like plants. The plants could be outside, but if you've got a cover over them, like a shirt and pants, it's not going to help the plant very much, is it? Same thing with us. Let's get those 2 tests done. Oh, I don't know why I put this here. So I think it's like it's out of order. Yes.
You're okay on your D3. If you're deficient, you are going to 2 hours. How much time would you need?
Okay, the question is, I'm good at 2 hours. In fact, 2 hours is probably good for me. I have to there's many variables that determine what your the answer to the question, which is how long do you have to be in the sun? What is the right dose? How long? There is no way to know that because there's too many darn variables. One is the time of day. The other is the season, the time of year. The other is your altitude, the latitude, the cloud cover, the pollution, your age. And there's probably half a dozen I forgot. All right? So the answer is, it depends. And the only way to know the answer to this, because just like high blood pressure, you cannot feel your vitamin D. There's no way to know. The only way to know, measure it. That's why you need to measure it. And if you're obsessive compulsive, like me, you might want to measure it every month or 2 months for a while until you get it there. Then maybe just once or twice a year. But you've got to measure it. I probably don't need to measure it. For me, I've become a bit more conservative in my recommendations for vitamin D levels. I used to recommend higher doses. I don't think it's higher. Remember, like most things in life, there's a Goldilocks dose, right? Too little is bad, too much is bad. You don't want to overdose. So my vitamin D level will go to 100 without swallowing a pill if I walk close to solar noon in the summer in Florida for 2 hours. That's not good. So I'm walking earlier. I start to go out at 9 o'clock, 8 o'clock. So I stay out of because the closer you are to solar noon, the more UVB you'll get. What is solar noon? What time is solar noon today? Just so you know, because we are in daylight saving times. So what time is solar noon? Come on, guess this. This is smart. Is it 12? No, it's 1 o'clock. Because daylight saving times is the perversion of truth. We move the clock forward. Is that it? I think so. It's bad. I mean, yes. The question is, what test, if you test it, what is the number? Can you read the screen? I didn't put it there. Sometimes I try to be creative. Yeah, that is the sun, and that's the vitamin D level. Yeah, that's the level you're shooting for, which is the same as vitamin D. I mean ferritin. So it's easy to remember, 40 to 60. Some people, I used to recommend higher, 80, even 100 if you had cancer, but I don't think so. I think you can overdose on vitamin D. Even if it's from the sun. You're less likely to do it from the sun because you've got feedback mechanisms which tends to shut down the production. But if you get, and I'm not saying everyone needs to be 2 hours out in the sun, because some of you may only need 5 minutes. That's it. Because once you hit your peak, you'll make 25, 30,000 units of vitamin D, like in 5 minutes. Now, if you've got deep, dark skin, or you're deeply tanned, or you're from Africa or the Middle East, you might need a few hours to do that. So, there should have been a lot more slides before this. I had to give an abbreviated talk, and I thought I had 40 minutes, but there is there's so many ways we can present this, but essentially there's the right foods to eat, or the foods that will optimize your longevity. And then there's the other factor is, when do you eat? Has anyone heard of something called intermittent fasting? Okay, it's become very popular. There are a number of ways that one can intermittently fast. There's probably half a dozen. You can do it every day, you can do it every other day, 5 days a week, two days off, 5 days on, 2 days off. And probably dozens of other ways. What I have started to coin, actually this is new, we just started coining this term, peak fasting is a very precise way to do intermittent fasting. It's a subset of intermittent fasting, but I think it's the ideal way that we're all designed to. Now, why would you think this would be important? Because ancestrally, we were never designed to eat 24/7, around the clock. Our bodies, your genes, your metabolism is designed to go for extended periods of time without food. And when you do that, you will optimize repair and regeneration. So Many of you may know, I used to say breakfast is the least important meal of the day. And that's true for most, but probably least true for a group like this. If you're an active farmer and you are going out shortly after you wake up and putting in a hard work, you've got to eat breakfast. The key is, though, you want to eat, this is another important principle, because when you dump in fuel into your body, you charge up that engine to make those mitochondria to make ATP. If you are giving your body fuel when you're not using it, you are profoundly screwing up your metabolism. The worst thing you can do is eat a big meal and go to sleep. Because you're going to have all this fuel dumping in, you're going to create ATP that your body doesn't need, and you're going to create more reactive oxygen species, generate free radicals, and cause molecular damage. So you want to ideally eat a very light dinner, especially if you're working hard in a day. Your biggest meal should be when you're moving or working the most. But you still need to integrate this period of time of intermittent fasting where you're not eating. And I believe it should be somewhere between, I said 14 here, but I think it's probably 13 to 18 hours. Key principle is don't eat before you go to bed. Remember I said you don't want to give your body fuel. If you can have a light meal, it's not too bad, but you clearly don't want to eat a big meal. And it's easiest for most people to take 3-hour jump start, go to bed, you're sleeping for 8 hours, hopefully, because that's an important principle. Don't delude yourself and think you're someone special and you can get by with 5 hours on a regular basis. You will not. Your health will suffer. Guaranteed. In fact, that's almost a prescription for getting overweight and type 2 diabetes if you don't sleep enough. You've got to sleep at least 6, and ideally 8 is what you need. So if you're sleeping for 8 hours, you're not eating for 3, you're already at 11. So you just don't eat breakfast, you delay breakfast for 2 to 6 hours. I mean, you don't have to stop. I mean, like for myself, I stop eating at about 4 o'clock, 5 o'clock, and I go to bed at 9. So that's like 4 or 5 hours that I'm not eating. So this way you can eat earlier when you wake up. But the key here, and why I call this peak fasting, is to understand that there's a process that occurs when you stop eating for a while. Your body will turn, if your especially when your body's adapted to burn fat as fuel, it will start to burn protein and burn your lean body mass for fuel, and you don't want to do that. So there's an optimum time, and ideally you can determine this time by measuring your blood glucose level to see when it rises. And for people who are really into this, I'm not suggesting anyone here needs to do this, but there's a number of blood glucose measuring devices that you can purchase. One is a Bayer Contour. It costs a giant $7 on Amazon, and the strips that you detect your blood cost 25 cents. So it's the cheapest one out there, and it's pretty accurate. So if you're interested in that, that's something you can do. And ideally, when your blood sugar starts to rise significantly, then you know it's time to eat. So it could be 13 hours, it could be 18. Now, it would make sense, the challenge, the reason why most of us get sick in this country, well, we have an epidemic of obesity and diabetes and Alzheimer's, heart disease and cancer that never existed a century ago. Never existed, right? A lot of it goes back to eating real food, but it's the type, we can eat really healthy, biodynamically, non-GMO, locally grown food and still screw ourselves up. If we're violating this principle, we have 95% of the fuel in our body is fat. Only 5% is sugar. It's stored as glycogen in our muscle and our liver. Doesn't it make sense if 95% of our fuel is fat that we might want to be optimized to burning that fuel instead, right? But I can assure you with an incredible degree of confidence that the vast majority of people in the United States today, I guess over 99%, and the vast majority of the people in this room are burning sugar as your primary fuel. It's easy to measure. You can, because if you're burning fat for fuel, you'll be able to measure something ketones in your blood typically, or your breath. So the key is to help us relearn how to burn fat. If you're interested, you can engage in a program that I'll discuss briefly that will allow you in about 2 to 3 weeks to make that transition so that you're burning fat. Because the problem is, and the reason why it's difficult to do this, and why most people are on sugar and using carbs as fuel, is that as your glycogen stores deplete, and you go between meals, your blood sugar falls, you feel dizzy, you don't have energy, you need fuel, you have to have fuel, but essentially if your body has forgotten and is not adapted to burn fat efficiently, you have no fuel. So the only thing that you can thrive on is sugar, unless you're willing to take the steps for a few weeks to teach your body how to learn to burn fat again, the way you were all designed to do, the system, the type of fuel that will burn clean. Just remember, there's only 2 fuels, primary fuels your body can burn, fat and sugar. Sugar is the dirty fuel. It generates 30% more reactive oxygen species. It is the stuff that is dirty smoke is coming out and blowing in your mitochondria and killing them prematurely. Does that mean you should never eat sugar or never burn sugar? No, there are times when you need it. You need metabolic flexibility. But you need to know how to burn fat. So, I talked about this before. These are the short-chain fatty acids that when you eat fiber, like that you can't break down, like grass that the cows are eating, this is what they turn into. Now here's an interesting thing. Most of you probably know, or would not find it hard to believe, that 1 in 4, going down to 1 in 3 adults in America are on statin drugs to control their cholesterol. 1 in 3 American adults over 40. Is there anyone here taking a statin? Few people. When you are taking a statin drug, it's a very, very dangerous proposition. They manipulate, they confuse you, they give you distorted statistics that says it's going to save your life. It won't, it doesn't. It's not going to, it might make you live a day or 2 longer, but at what risk? If you're lucky. Statins are generic. I think they've sold, I've just heard a recent statistic that over $1 trillion of statin drugs. $1 trillion. That's a lot of money for a drug. Yes. Okay, comment was that they want to put it in their water supply. Yes, they'd like to because they believe it works. Because there are very powerful forces that have used very clever, sophisticated marketing tools to convince and manipulate the medical profession to come to that belief. That they have the preposterous suggestion where they're going to put in a water supply. So, all statins inhibit an enzyme in the liver called HMG coenzyme A reductase. That's the enzyme that causes your liver to make cholesterol. So they shut off that enzyme and your cholesterol levels drop. Unfortunately, that enzyme does a few other things. It's responsible for making a really powerful and important nutrient for the mitochondria called coenzyme Q10, ubiquinone, or the reduced version, which is ubiquinol. It also is responsible for converting vitamin K1 to K2, really important nutrient for bone and heart health. But what virtually no one knows, I would say 99% of doctors don't understand, is that that same enzyme is responsible for your body making ketones. So if you put that cow on a statin, that cow would die. Because it couldn't make ketones and that's what it's living on. That cow would die from the statin. I don't know that that study's been done, but that's exactly what you would predict. They have to be the appropriate dose, of course. Human dose wouldn't work because the cows are big. So you shut off ketone productions, they will certainly not thrive, and they likely die. So what is a ketone? It's the end result. It's basically a water-soluble fat. And it gets transported into your blood and passes right from your blood into the mitochondria, and it burns very clean. It doesn't require a transport mechanism like L-carnitine to shuttle it back in. And it really burns incredibly clean. So there's like no smoke coming from this thing. And there's incredibly exciting science that's out now that's showing that this is used for you can essentially treat and reverse Alzheimer's disease with these. Some of you may know of Mary Newport, who's a physician, and her husband is a physician, got Alzheimer's and started doing this and using things like coconut oil and MCT oils, which generate lots of MCTs if you're eating the right types of food. These ketones do another component, they have another benefit. To me, it's one of the primary, there's two primary benefits. One of them is that they have a profoundly powerful appetite suppressant mechanism. So much so that you could have your favorite food sitting in front of you, whatever that is, ice cream, cake, pizza, you name it. Whatever that food is, prepared the most elegant way that would be most appealing to you. And if you have high ketone levels, your cravings, your desire for that food will almost be non-existent. Could you eat it? Sure. Would you enjoy it? I'm sure. But you wouldn't have a craving for it. It literally is nothing short of a miracle when you are burning fat as primary fuel and your ketone levels are therapeutic. But the other important thing that they do, you see, your two most energy-dense organs are your brain and your heart. And they run most efficiently on fat, not sugar. And has anyone seen the movie Limitless with Brad Cooper? Really good movie, wasn't it? And then now there's a TV series called Limitless too, which also has Brad Cooper in it, but he's not the primary star. So in that movie, the scientists develop a pill called AZT, which when taken, essentially turns these guys into supercomputers that are more intelligent than like the whole planet put together. And it's profoundly entertaining to watch. But that's almost, to me, the most accurate description of what occurs when you're burning ketones for fuel in your brain. It's like working on steroids. You just never had more profound clarity and thinking, and it's just consistent across the board. Everyone I know, seen, talked to, or read describes this to a T. Your brain works incredibly. And that's, for most people, the most profound benefit and significant motivation to stay on this type of system because of the way you feel. Now, this is a picture of me in high school. And you can see the reason I got so ripped when I was in high school is not because I was doing a lot of abdominal work. It was because I was consuming a low-carb, net-carb, high-fat diet. That's what does that. Now, there's a lot of, I got the slides mixed up here. So you're going to, what is this? High net carb, or low net carb, high fat diet, and low protein. Is that an Atkins? How does that compare to Atkins? Is that a reasonable question? You're probably wondering, right? Atkins was similar. Atkins was clearly low carb. Many people got benefit, lost weight, but what Atkins failed to understand and caused harm and damage to many people, that was the only part of his program, was low carb. And that is a good thing. Low carb is a good thing. Now, when I say low carb, that's sort of an abbreviation. I mean low net carb. Remember, that cow was on a low carb diet, right? Even though that's all he was eating was grass. Because low net carb is total carbs, which in the cow's case might be probably a few kilograms. I don't know how much grass a cow eats a day, but I'm sure it's a few kilograms, maybe 10, 20 kilograms of hay. I don't know. So, but like only a few hundred grams were sugars that was digestible. So low net carb, which is total carbs minus fiber. That's what you're talking about. And that's what Atkins promoted, and it's helpful. But what's even more, there's two flaws in Atkins' approach. One is that he didn't understand the importance of the quality of the fat. You need high quality fats. It's not just any fat. And the other, probably more serious one, because what's more dangerous than carbohydrates is too much protein. Too much protein. And you know, that's actually, you're thinking, God, you know, that's what we're here, we're growing beef, right? But that's actually a good thing. You know, because what is the most consistent objection that consumers have to your product? The price, right? So wouldn't it be great if they got the nutrient-dense, high-quality, omega-3 rich foods that you guys are facilitating, and it didn't cost them as much because they only needed to eat a third of what they're eating now. And by doing so, they improve their health. So the key point here is too much protein is worse than too much carbs. And you're going to say, why? Why? What? Did I lose my rocker? Did I watch this movie and go nuts? No. There's recent science that shows there's a pathway. It's called mTOR, which is an acronym. It stands for mammalian target of rapamycin. Rapamycin is an anti-cancer agent. That's how they found this thing initially. And it is one of the most profoundly powerful signaling pathways in your body. We've only known about it for 10 or 15 years. Literally 20 years after I graduated med school. This was not known. This is new science. And even then, this is new science in the research community. It's virtually unknown in the clinical community. So this is it's kind of like insulin. You know, if you have high insulin levels, that's a problem. You become insulin resistant. So very similar to mTOR, you want low mTOR levels. There are times when you need mTOR to be elevated when you're growing and such, but normally you want it low because that's going to improve these things like autophagy that I talked about earlier, which will increase your risk of cancer, and something called mitochondrial biogenesis, which is the ability of your mitochondria to repair, regenerate, and reproduce themselves. And if you have elevated mTORs, it will not do that. It will suppress it. Interesting, the other powerful, potent stimulator of mitochondrial biogenesis is peak fasting. When you don't give your body the calories all day long, it's like a hormetic stressor, and it causes your body to it's like exercise, which is also increasing mitochondrial biogenesis. But you know that if you don't exercise, and by exercise, I don't mean necessarily going to the gym, because I know many people in here never need to see the inside of a gym. You have the best gym in the world with the work you're doing. That's not most of us. It's certainly not me. But ideally, we were designed to be working. And most of us do not do physical work to earn our living. That's why we have to exercise. We have to compensate for it. But if you were exercising, you know, you didn't exercise, and you weren't doing physical work, you'd be pretty seriously ill. You need to exercise. But if you did too much, it'd be bad too, right? It's the Goldilocks dose. So, I'm sure the other important thing, all this stuff about optimizing mitochondria and cancer, I forgot the most important disease that optimizing mitochondrial dysfunction addresses. It's a disease that every single person in this room has, I guarantee you 100%. Everyone in this room has this disease. Do you know what that disease is called? Hint. It's up there, yes. Aging. We're all aging. Now, if you're in your 20s and 30s, who cares, right? Well, you'll care eventually. If you're much older, then you know, wouldn't it be nice to put the brakes on the aging system? There is nothing more profoundly effective at slowing the aging process than inhibiting mTOR. So much so that they even have drugs that treat diabetes, metformin, that a lot of anti-aging enthusiasts are using. I think there's better ways of using metformin. I think it's far more effective to use your diet strategies, which includes the food you're eating and the timing of your food. And in fact, many of you heard that calorie restriction universally has been shown for many decades to increase lifespan of animals and even humans, right? But it's just enormously difficult to do. Well, you know what? You don't have to decrease your calories. In fact, I eat between 4,000 and 5,000 calories a day. I don't look like it, but I do. Because fat goes for a free ride. It doesn't count. It does not stimulate mTOR. It doesn't stimulate mTOR. Insulin will, or carbohydrates will, and amino acids will. I think we talked about this. This was a description of my diet a few months ago, but it's actually changed. My fat now is up to about 85%. Protein is down to about 8%. Fiber carbs are about 8%, and non-fiber carbs are under 5%, I think 3 or 4%. But that's a lot different than what you see. Most people would see this and they would say it's crazy. And if you look at the fine details in the fat yellow section, that as one of the presenters earlier today mentioned, that omega-6, and many people here know that 6-to-3 ratio is crucial, but you don't want it. There's only 3 types of fats that you can have, right? Monounsaturated, saturated, and polyunsaturated. Polys are really designed to divide it into 2 subsets, omega-6 and omega-3. You don't need a lot of those things. You can get really, really sick eating a lot. This is not just a high-fat diet. It's very specific. Most of the fat is either monos or saturated. It's just less than 10% is polyunsaturated fats. And that's what they were promoting, is vegetable oils, which I believe is responsible for causing the epidemic of heart disease in the beginning of the 20th century, that the nutcake, Ansel Keys, to start the low-fat diet myth, which literally screwed up my life, first part of my life. I mean, because almost everyone, from the 60s onward until about the 80s, it was before he started waking up, and probably into the 90s, was doing low fat. I mean, no one disputed it. That was the way that you got healthy, is low fat. The lower the better. All the way to the ridiculousness of Nathan Pritikin, less than 10% fat. So the problem is that before 1900, we had very little of these vegetable oils. And by 2000, we were up to 75 pounds a year. You just can't have a lot of this. It actually damages your mitochondria profoundly. So you want to avoid them, processed oils. Now, does anyone here, now flaxseed oil is omega-3, and I believe you do need some vegetable-based omega-3s. It has an important omega-3 in there called alpha-linoleic acid, ALA, which men don't convert as well as women, but it does convert to higher chains. You need EPA and DHA, which usually come from marine sources. But does anyone here have flax oil at home? Okay, let me see your hands high. I want to see how many there are. Okay, that's great, because this is going to be really helpful. What you have to do, you don't have to, but I strongly recommend it. Think of a neighbor or a relative that you don't like, and give them that flaxseed oil. If you want to be kind, throw it away immediately as soon as you get home and put it in your notes. You do not want to have flaxseed oil. Do not have it. It's rancid. Guaranteed 100%. Doesn't mean you can't have flax seeds, which you grind fresh from organic flax seeds in a coffee grinder and have a tablespoon a day. That's what I do. I have a tablespoon of flax seeds a day. Good thing, because then you're getting the oil that's not oxidized, but you're also getting important other accessory nutrients. In the case of flax seeds, lignans, which are fibers that form very protective nutrients in your colon. So you want to eat whole foods, not refined flax oil. That literally holds true for most other oils. The only other oil exception would be olive oil and coconut oil, MCT oil. If you have olive oil, I'm sure most of you consume it. If you do that regularly and have not seen the 60 Minutes presentation that was in the last few months, please watch it. You can see it free online. There's no charge. It will show you that 80% of the olive oil in the United States is from the Italian mafia influence. This is on 60 Minutes. I mean, I'm not a huge fan of 60 Minutes, but they have some pretty incredible investigative journalists. And so what? What does that mean? It means that they adulterate it, that they put in vegetable oil, like soybean or corn or safflower. And you're having omega-6 oils, not monounsaturates. So a little hint, would you like a hint to get cheap, authentic olive oil? Costco. They certify it, and they check it. You know, nothing gets through there that it's adulterated. And they've got pretty good price. I used to go to Costco maybe 10 years ago, but where I live in Florida, there's not one that's more than 100 miles away. So, and I know many of you live rurally, so that's not an option. But for those who do have one available, that works. Talked about exercise increasing mitochondrial biogenesis. Do you know what time it is? Who knows what time it is? No, it's time to sit up. Stand up. There you go. You know what you did? There you go, stretch. Because that just increased, you've been sitting down too long. I'm the only one up here getting to be standing. And you can, and as long as you're not obstructing your neighbor's view, you can stand up as long as you like. I don't care. But what you've done when you do that is you increase something called BDNF, which is short for brain-derived neurotrophic factor. Really important. Sitting is the new smoking. We all need exercise, as I said, but many of you here do never need to go into a gym if you're just doing your work. The ideal exercise is to move all day long in all different positions and rotations and strategies so that your body gets what it was designed to get. It's a requirement that we have. And we ideally need about 7,000 steps a day. 10,000 would be a little better. There's devices like Fitbits, which is probably one of the best ones. I wear one, and you know, not only does it tell you how many steps you have, but you can also tells you how much sleep you have, so you're not deluding yourself, knowing that just because you're in bed doesn't mean you're sleeping. Remember, you need 8 hours, so that means you're going to have to be in bed for 8.5 to 9 hours. It means you have to go to bed early enough. Exercise, I didn't know this. I've been exercising since 1968, when Ken Cooper, I read his book Aerobics in 68. And like 20 years later, they came out with these studies that shows exercise radically reduces cancer risk. I had no idea. I thought it was dropping insulin levels. It doesn't do that. It does that because exercise increases mitochondrial biogenesis, one of the most profound stimulants along with peak fasting. High-fat diet. It's actually a high-fat burning diet would be more accurate. You want to give your body the ability to burn fat, to remember how to burn fat. Not only will it treat cancer, and I think it's criminally, medically, reprehensibly negligent not to have anyone undergoing cancer to integrate this into whatever program they're doing, whether it's conventional chemotherapy or radiotherapy, is to use this as part of it. We're actually engaging in a process. I'm writing a new book and developing resources to help people integrate this in there, and training certified nutritionists so they can consult with people how to implement this. It's also good, as I mentioned, for anti-aging, heart disease, diabetes, obesity, and neurodegenerative diseases and seizures. It was actually done for seizures. These are some of the pathways. Not only does it affect insulin and leptin, but there's this really important pathways like PGC1 alpha and mTOR, P53 and AMPK. Interestingly, there's another thing. There's a few supplements, resveratrol and berberine are useful, but cold exposure is really a profoundly effective stimulus. It does, especially if you have pain. Like you could jump in a cold plunge pool or a cold lake mean, you don't want to kill yourself, and if you have some heart problems, you have to be careful. But unbelievable what that does to you. It increases something called norepinephrine into your body, which will radically improve your pain threshold. It'll improve a lot of other hormonal signals, and it increases mitochondrial biogenesis. Just something as simple as cold exposure. So, you know, I've got a website, as I mentioned. John Woods through US Wellness was one of the first products we have. We sell other items as resources, but I donate 20% of our profits to initiatives, and one of them was an important one you may know, which was helping to label GMOs. And you know, I actually with Ronnie Cummins in 2011, 5 years ago, we formed a coalition. And Ronnie Cummins from Organic Consumers Association is really the person who came up with this brilliant idea. And so he was familiar with the direct ballot initiative, which we implemented I mean, it cost us $10 million to engage in this campaign. So I donated a big chunk, and that catalyzed other people. We were actually able to do it. And even though we lost that specific initiative, we gained the momentum. And now we've got the people running scared. We actually have Vermont has passed legislation ready to go into effect into July, unless the DARK Act, the Deny Americans the Right to Know, gets implemented, which the Senate may do in a few weeks. They were very cleverly, you know, the industry's not going to go down without us swinging on this one. So we don't know what's going to happen with it. But you know, Americans need the right to know. So, and I think it's an important principle. And we're involved with other things. But the key thing here is to eat real foods. I would need another 2 hours to tell you the specifics of how to implement a high fat burning diet, but essentially it's really simple. Low net carbs, below 30 to 50 grams a day. Net carbs being total carbs minus fiber. High fat, in about the percentages I just showed. And keeping your protein down to 1 gram per kilogram of lean body mass. So what does that mean? That means for most people in this room, that's about 30 to 60, maybe 70 grams of protein a day. Now that doesn't mean 60 grams of beef, because beef has a lot less protein. 60 grams of beef has a lot less protein than 60 grams. So you have to look it up in tables. And there's nutrient tracker programs available on the market that you can do this, and there's no charge to use them. But you're somewhere in that range. Ideally, you take your percentage of body fat, but it's unusual for someone to be less than 10% body fat. Most people are 20% or more. So if you weigh 100, 200 pounds and you're 20% body fat, then you're literally, that would be 160 pounds of lean body mass, and that's what you make your calculation from. And a gram per kilogram is essentially half a gram per pound. So in that case, it would be a 200-pound male, 20% body fat would be about 80 grams a pound, 80 grams of protein. But most women are a lot smaller, and you know, you're going to probably be closer to 30 or 40 grams. So the protein is key. Don't overeat. The good news for all of us, because if we're selling beef or protein, the healthy protein, your consumers are going to need much less, which means they can afford it. They don't have to eat an 8-ounce, 12-ounce piece of meat. Now, if you're going to go out to eat and you're presented with a big portion of meat, I would just encourage you to limit it. Start cutting it down, because that will clearly activate your mTOR pathway. And then cut it down. Don't throw it away. Have them wrap it up and take it home. Eat it the next day. So, you know, it's just a way to be more economical. It's a little bit easier on the environment. And most importantly, it's going to improve your health and to prevent all this degenerative disease. So, key thing though is to eat real food, and I think that's the end of it. I could take a few more questions now, but I'm really passionate about this topic, and I think it's going to have profound influence to improve not only your health, but the health of your family and friends. Yes.